This is a very challenging question. Cot inverse 1 minus x plus x square. It does not strike to me that which formula to be used here. See, it is the application of this formula that cot inverse x is tan inverse 1 by x. It is the same thing. Tan inverse 1 by x equal to cot inverse x. Make use of this formula. So cot inverse of this expression may be written as tan inverse of 1 upon 1 minus x plus x square. And now look at the denominator. If I take a negative sign common here, rather negative x, what do you get? You get in the denominator 1 minus x common, 1 minus x here. And if I want to replace this 1 by x minus 1 by x, what do you get? You get x minus 1 plus x. No, I want 1. So you make it plus here. So it is x plus 1 minus x. And now you read it like this. X plus y over 1 minus xy. Tan inverse x plus y over 1 minus xy we can work out as tan inverse x plus tan inverse y. The only difference that in place of x, of course, we have x, but in place of y we have 1 minus x. So using this formula, that is tan inverse x plus y over 1 minus xy equal to tan inverse x plus tan inverse y. We get tan inverse x plus tan inverse 1 minus x. That's it. Yes, this is again a good question. Directly it doesn't look any formula pattern, but you know that here if it is sine inverse of an expression, so inside somehow it would get something like sine theta. Just rewrite the expression as divide by 13 separately. You get 5 by 13x plus 12 by 13 under the root 1 minus x square. We want something like sine theta here. Do you find it a pattern like sine A, cos B, cos A, sine B kind? So let's x is equal to sine theta. No doubt, finally we can replace theta by sine inverse x. So we'll put x is equal to sine theta. And because we want sine formula, so it could be like sine theta cos phi. So 5 by 13 I should replace by cos phi, or phi equal to cos inverse 5 by 13. What will be sine phi? Just using the triangle method, a right triangle, if cos is 5 by 13, that is base by hypotenuse, it will be easy for you to work out. Perpendicular will be 12. And then the value of sine phi will be 12 by 13. And now you come back to the expression. It is sine inverse x, I write sine theta, 5 by 13 is cos phi, plus 12 by 13 is sine phi. And what about under root 1 minus sine square theta? Because if you replace x by sine theta, so under root 1 minus x square will be under root 1 minus sine square theta. So 1 minus sine square theta is cos square theta. So it will be under the root cos square theta. In the next step you get sine inverse sine theta cos phi plus sine phi cos theta. Or shall I read it sine theta cos phi plus cos theta sine phi, which is nothing but the expansion of sine theta plus phi. So sine inverse of sine theta plus phi. And now sine inverse of sine theta you know is theta, so you get theta plus phi. Theta, you know, as initially we took x is equal to sine theta, so theta can be replaced by sine inverse x. What was the other assumption? We took cos phi equal to phi by 13, so phi can be replaced by cos inverse phi by 13. So the final simplified form is sine inverse x plus cos inverse phi by 13.